Hello, and this is an informative presentation about fiberglass rebar, or GFRP, by Carl Stady, Ben Green, and Nolan Norris. Here's our overview. We're going to talk a little bit about it, how it's made, how and where it is used, the pros, the cons, the environmental advantages, and a little bit of a comparison to steel rebar. Gfrp was first manufactured in the United States in 1984 by the Kodiak Company. Fiberglass rebar was designed for applications where concrete is exposed to water, salts, and other chemicals. The first vehicular structure built using solely FRP was McKinleyville Bridge in 1996. As you can see in this picture, as of just under a year ago, it still stands strong. Gfrp is manufactured in factories using large machines that apply a process called pultrusion. The Gfrp consists of thousands of glass filaments that are saturated with an epoxy resin, then pulled through a gauge die. The FRP is then helically wrapped under tension to create the bar shape and ran through a multi-temperatured process to produce the proper cure. Finally, the bars are cut into usable lengths. This diagram shows you what the machinery looks like and what the process looks like. Here is a diagram of the actual pultrusion process. As you can see, there's multiple different yarns, all being twined up into the shape of a bar.
How Gfrp rebar is used. The primary function of Gfrp is to reinforce the structural strength of concrete. GFP is set like traditional steel rebar inside of the concrete. GFRP is versatile enough to perform the same task as conventional steel rebar. GFRP can be used in columns, footings, beams, slabs on grades, etc. as like steel rebar. It can also be used on bridge decks, barrier walls, roads, parkades, concrete slabs, power generators, MRI, tunneling, temporary reinforcement, dams, seawalls, and marine applications. Compared to steel rebar, GFRP is paintable and can be cut flush for no patching. The weight is about 1/4 of that of steel. GFRP has twice the tensile strength and compression strength than steel rebar. GFRP does not interfere with operation of sensitive electronic devices. It is impervious to salts and other chemicals. Experiences 2.5 times less cracking than steel reinforcement. It's non-flammable, and also on a bridge deck slab exposed to cyclic fatigue loads, GFRP is about 440 thousandths compared to 40,000 of steel rebar. On some environmental issues, GFRP does not leach toxins or corrode when installed in water application. It contains 2% post-industrial recycled content, and during transport it emits less GHGs, which are greenhouse gases, than conventional steel rebar.
Here are some pros. The first and foremost advantage of glass fiber reinforced polymer bars is their non-corrosive nature. Chemical-induced corrosion of steel reinforcing bars is the primary contributor of premature deterioration of concrete structures. Use of GFRP bars as top mat reinforcing allows for a thicker cover over the steel reinforcing of a bottom mat, significantly increasing the time that corrosive properties would seep into a slab or bridge deck, causing degradation. Forcing these properties to penetrate deeper will result in an increase in the service life and reduce life cycle costs of the structure. The development and implementation of GFRP was initially to solve the corrosion of steel issue. As the product has matured, its applications and advantages have grown and become more apparent. And now the cons. The stress-strain behavior of GFRP bars is linear elastic to failure, with no yield plateau. This means that there is not much yield before it fails. Proper design of concrete reinforced with mild steel bars ensures that the steel yields before the concrete crushes. With GFRP reinforcement, designs are encouraged in which the concrete crushes before the GFRP ruptures. Although GFRP does not corrode, it does experience a loss of strength with time, particularly in an alkaline environment such as concrete. The use of GFRP as reinforcement for concrete is still a relatively new technology, and more information about its behavior is needed to safely design a wider variety of structures.
Hi, I'm Carl,
I'm Ben.
I'm Nolan.
and we've been talking about GFBR.
Oh, it's easy. PRGP.
RTF?
No, I know. Fibar.
No. Fubar.
What?
Fubar?
No, Fibar. You know, like, finally I'll be able to ask for a raise.
Oh.